Okay. Next question related to electricity. Figure 8.1 shows the diagram, the circuit diagram of a temperature gauge. It contains an ammeter, a thermistor, a fixed resistor, R, and a battery. The current is measured at different temperatures and a graph of the result is shown. So in this graph, we can see that the temperature when increases, the amount of current is also increasing, but they are not directly proportional. It is a curve which shows that they are related to each other directly, but they are not directly proportional. State how the resistance of the thermistor changes with the temperature and explain how figure 8.1 shows this. Number one, how the resistance of the thermistor changes with temperature. We would say that resistance decreases when temperature increases. This is the general behavior of a thermistor. Explain how the figure 8.2 shows this. The graph shows this. So it is evident that current is increasing when the temperature increases, which means that resistance is decreasing, therefore the current is increasing. Resistance and current are used for the measurement of temperature. State one other physical property that is used for measurement of temperature. So for example, we could use the volume for the measurement of temperature, the change in the volume. So volume of liquids or gases could be used to measure the temperature. A temperature scale involves the use of fixed points. State what is meant by the ice point. The temperature at which water freezes and converts into ice, or melts and converts from ice to liquid. The steam point. The temperature at which water boils, means it changes from liquid to gas, or it condenses and changes from steam to liquid water. At 80 degrees centigrade, the potential difference PD across the thermistor is 3.6 volts. State what is meant by the potential difference. The energy transferred per unit charge. The energy transferred per unit charge when passing through a component of the circuit. So whatever is the energy transferred from charge is taking place, that would be the potential difference of the component. The next part says calculate the resistance of the thermistor when the temperature is 80 degrees centigrade. Now, for this, we have to use this graph. And at 80 degrees centigrade, we can see that the current is 0.014 amperes. So the value of current is to be noted from the graph 0.014 amperes. And secondly, we were given with the information that at 80 degrees centigrade, the potential difference across the thermistor was 3.6 volts. So V is 3.6 volts. And now we have to find the value of the resistance. We would be using the formula of Ohm's law. V is equal to IR. R is V divided by current. Voltage is 3.6 and current is 0.014. So answer is 260 ohms. So the resistance of the thermistor at 80 is 260 ohms. The electromotive force EMF of the battery is 25 volts. Calculate the resistance of resistor R. Now we can see that it is a series circuit and 25 volts is the EMF of the battery. Similarly, 3.6 volts is the voltage across the thermistor, which shows that the voltage across the resistor would be, when we subtract 3.6 from 25, and it gives us a value of 21.4 volts. In a series circuit, the total voltage or the EMF is divided amongst the components. So there are only two components. If the thermistor voltage share is 3.6, then the remaining voltage would be the voltage share of the resistor. Similarly, it is a series circuit, so the current through all of the circuit is going to remain the same. And from the previous part, we know that the current was 0.014 amperes. So the same current is going to flow through the circuit. So I'm noting down the two values, that the voltage for the resistor R is 21.4 volts and the current is 0.014 amperes. So resistance would be voltage divided by current. Voltage is 21.4 and current is 0.014. So the answer is 15,000 ohms. Resistance of permanent resistor here is 15,000 ohms. The current scale on the ammeter is linear. Using values from figure 8.2, a student marks the scale on the ammeter with temperature values that correspond to the values of the current. The temperature is then read directly from the thermometer scale on the ammeter. State what is meant by a sensitive thermometer. A thermometer in which the quantity, like the volume of the liquid, changes a lot for a change of 1 degree centigrade. So if the quantity or the liquid or the volume is changing uh, considerably, and it is changing a lot for the temperature change, then the thermometer is called sensitive thermometer. State and explain at which temperatures this thermometer is most sensitive. When the temperature is going beyond 80, then the smaller change in temperatures is creating a larger change in the current. Similarly, when it was at 40 and the temperature was changing from 40 towards 60, the current was not increasing that much. So it means that it is more sensitive at higher temperatures, and the reason is because there is larger change in the current. So the region where it is showing the larger change in the current, that is where the temperature or the thermometer was more sensitive. The temperature gauge is used to measure the temperature of a room. Suggest why the temperature obtained using the gauge is slightly higher than the actual temperature of the room. The reason is there is some heat produced in the components of the circuit, like the thermistor or the resistor. So they are passing current and heat is being generated there also. So that is why the effect of that heat would also be indicated on the thermometer, and the reading shown by the thermometer would be a little larger than the actual temperature of the surroundings.